Okay, back with you guys after having a little lunch there, recharging the battery. And again, I had spent some time on the cabinet there in the first half of the day. And on day 9, when we left off, again, I had started working a little bit on the B plus side of the circuit as well by getting some new electrolytic capacitors tied in to a terminal strip. Anyway, I spent just a bit more time off camera and was just kind of probing around looking at some of the component values, starting with the RF section off of the type 58 tube. Anyway, see some odd things, so I think what I'm going to do, I'm going to hand draw the schematic. Again, these TRF circuits are very, very simple, but I'm going to just do a hand drawing of all the components and then compare that to the 4T schematic or the 30 schematic here, and just see what the differences are. So I'll be doing that just for a bit, then again we'll continue this video and I'll try to point out some of the differences that I'm finding underneath the chassis here compared to the schematic. Best I can tell, I've got things squared up now, and the schematic matches the what I see on the inside of the radio. A little confusing because some of these grids are not really associated with their location according to the tube manual. So some of my original documentation for pinouts was adjusted accordingly after tracing everything out. And you can see my scribbly mess right here. I wouldn't ordinarily go to that kind of trouble, but it's kind of fun and interesting to see how everything connected in the radio and try to match it back to the schematic itself. Because some of these parts and pieces, are scattered about inside the radio itself physically. Anyway, there's definitely a few resistor values that are incorrect. So most likely they use what they had on hand. And then we'll get rid of those ceramic disc caps as well. Okay, I'm going to start right down on this end of the radio and just work my way right back here toward the electrolytics. Again, in no particular order. I'm going to just refer back to my notes here and get rid of the resistors here that are out of spec or the wrong ones, and again get rid of these ceramic caps as well. We'll start here with the big guy, .25 microfarad cap. From ground to here, then again I'll look back at this resistor as well, since we're going to be tying into the same point right here, and see if it needs to come out as well. Again, I mentioned starting on this end, a couple things here that we'll address. Again, we'll get rid of this old wax cap here, again 0.25 microfarads. We'll check this modern day cap here on the LCR and just make sure it's good. I don't typically do that. I just throw them in, but not a bad habit to do that. You can definitely have a failed component right out of the box. This is R7 that I'll be replacing here, and let's see, that's a 40K. I'm redoing the math right in my head again. You've got the body yellow, which is 4, and then you've got the black at the end, which is 0, and then you've got the orange dot. So just remember bed is the way I do it, body, end, dot. So that's 40,000, and when I read it just a bit ago, I think it read about 49. Again, that was in circuit. So I've got a modern day cap here that we'll put in, and the schematic calls for a 25,000. So let's look at those here on the LCR meter and just make sure the capacitor and this new resistor is good to go. There, you got the cap hooked up here. We'll just let this thing auto and you can see we're good. And again, the see if I can move this where you guys can see it, hopefully on camera. Hopefully there's not too much of a glare there, but 247.6, and again this is in nanofarads, so I can just move the decimal point back 3 locations, or divide this number by 1,000. So again, 0.247, and again this particular unit is 0.25. Let's check this resistor value and see if I pulled out the correct one. And there you have it, 24.86K, and again K representing 1,000, so 24.87 times 1,000 for those out there new in the hobby, so 25,000, close enough. And let's see, I already double checked that on the schematic, so let's get both these components here out, get some new ones in. We'll test this too, just for the fun of it, and see what it reads here. If I left enough lead on it there. I'm going to use the coil method, and lots of folks do that. And again, on some of these I may desolder completely, but in this case I don't want to go to the hassle of resoldering here to the chassis. Again, that's probably not the best solder joint, but we'll double check them here just to make sure that our resistance reading between chassis and the leads here are in good shape, and we don't need to redo any of these solder joints here. Let me just clean this off just for giggles. We'll just go ahead and check this and see what the capacitance shows. Again, that's just capacitance, and again not checking to see if there's leakage, but we can do that real quick too on the VOM, and just see if we read any resistance on this old Sprague wax cap. Alright, let's check this capacitor real quick. Again, we're not looking for leakage or anything, which is another test, but just pure capacitance, and let's see what we get. Alright, 344.8 nanofarads, or 0.34 microfarads. So again, it's spec'd at 0.25, so it's a little out of spec. Let's see what the DC resistance is of this old cap. So you can see there's definitely some DC resistance, so this cap is definitely leaky. Let's check the replacement and see what we get. Alright, what I would expect to see. That just shows you how important it is to get these old caps out. Let's see the other side of R7. I said, looking back here at my notes over my head. Goes to ground. I mean, in this case here, since I've got to desolder the resistor here, we'll just clean up here and solder directly back to this point, and get this whole area right here cleaned up. Real quick, there's the reading. You can see, looking at the resistance I had called out when I measured it there in circuit, around 49K. So you can see, since one lead went directly to ground, there really wasn't much influence, and the tubes are out as well. So not much of a change. And again, we'll go back with the 25,000. Get this under camera so you guys can see. 10 the soldering iron here, and just put a little extra solder on it because it's going to help loosen up the solder here. Alright, I've got safety glasses on here. just for parts and pieces. Sometimes you'll see me work without them, and I'll do this. But better to have your safety glasses on if you're soldering anyway. And again, that needs to be connected here between those 2 points. So let me just clean up. Alright, there we go. Get a little alcohol out here, get the acid brush, and clean up this terminal here. There's the dispenser that I use as well. Comes in handy. And again, you can see I've got the brush cut back here. Just want to get in there and make sure we got a nice clean connection point to solder to. And before I'm done, I'll go back in here and take the acid brush and with some alcohol and just kind of wipe the whole chassis down, just to clean everything up. Alright, I think we're good there. Let's do a dry fit again. I'm not going to use any heat shrink or anything in this area just because of my proximity here to the tube socket, and I'm going to keep my lead lengths as short as possible. And I'm going to use this outside hole right here for the resistor. And again, I'll bring this up as such, and then again we'll form the cap here if I can find it. Let's see, I want the cap here running. I think I'll have it run this way, and that will match my orientation for the other caps here. So we'll have it lay in this area. As I mentioned in the other video, it's really important, in my opinion, to have the component values facing towards you, and when possible I like the orientation the same. Okay, I'm just cutting a piece of heat shrink. And one of my subscribers was asking me what I was using when I was going back over the capacitor, and all that is, again, is just my little small heat gun, you can see, and I just use it to melt the shrink. Lots of times I don't even do that, but it's really a good habit to get into. And again, I'll bring that up and over to a certain point, just where it won't pull loose. See if I can do this here and keep the soldering iron out of the camera and see what I'm doing. What I'm doing is just making sure those solder joints to the chassis are good, and they are. And let's just see what this resistor is here. Okay, we're good. You can see 2489, that's about where we started. So just under the 25K. Alright, let's move along here. Let me get back over here and look at my notes on these two resistors. And again, we want to get these ceramics out. And this is the one again that affects the frequency response. So we'll probably just go ahead and go back with what the schematic called out. Gary, if you're watching, thanks for clarifying that. And I went back to my 412T schematic as well. And it is a 0.006, and again this was a 0.001, and again this is where everything was tied in here to the tone control. So we'll just go back with the schematic value and see how the performance is. Both of these resistors here need to go. One reads high and the other one's the wrong value. I think this one is the correct. Look back at my notes, but again, we'll go ahead and get both of these resistors replaced again, assuming I've got the right value. Let me go check my seed stock here, see what I've got. Alright, just checking back on my notes here. 500K, 100K is what's needed. So again, I'll double check here before I solder them in, but let me go ahead and get these cut out. And we'll do one at a time here. This is where I need to get this cap out too, so, and this other cap. So we'll go ahead and clean up all this at one time. Hope I got the values I need here since I'm doing the old cut. Thought about sticking this radio in my chassis stand. You guys think you probably had a chance to see it. For those that have been following along, it really works well, but this chassis again being so small, I elected not to. Would have probably made it a lot easier though. You see how this thing's wanting to move around. You know, sometimes you just do your best to show this on camera, but again, you've got these crazy angles you've got to be at, so it's almost impossible to show some of the work. There, I've got a nice cold solder joint there now. And videoing slows you way down on the doing the actual work as well. You can get in here and make really quick work of this stuff if you're not videoing. Alright, let's see what's left here. Yeah, I finally got that old leads off of there. Pretty messy. The terminal looks nice and clean there now. Let me just go ahead and do a dry fit here on the correct resistor. And what I say, that one was a 500K, I think it's supposed to be there. Let me double check myself here, make sure I get the right one, and we'll just go ahead and fit it in there. Then we'll start looking for these other cap values that we need. Yeah, just double checking the resistors here. You can see this one's good to go as well. So 496, and this one should be 500K. Alright, I'm going to have to get my hands down in here in front of the camera here just to dress this up. Alright, we'll lay that there for now. Let me go ahead and check this other cap value here and get it attached as well as this. Okay, just looking at my notes here again, this is a 0.01, and again, just looking at my notes, that should be a 0.02 microfarad. And again, that's running from the grid 1 on the 2A5 back to the plate of the 57. So that's the orientation, and we just double check again on the value. Said that was C3. Yep, 0.02 microfarads. By the way, these other caps up here, the 0.047 on the schematic, they're called out to be 0.05s, and I'm going to just leave those. And the orientation, you can see, is a little different on both, but let's see. I think I'll go ahead and do my orientation this way. Okay, and we'll just leave that up for now. Back on this cap right here, again, C4. Just looking at the schematic again, just one more time. Again, it's 0.0005. So that's 500 picofarads. And that's what we've got here. Let me just double check this one on the LCR here, just make sure we're good. And now you can see we're really close there, 501. And again, a 0.001 was in there, so not sure how critical that is. It's off the plate, but it is odd that they called for a pico value. Excuse me, it is odd that they called for a pico value in that area, but that's what we'll go back with. Alright, this goes to ground, and I'm going to take advantage of this just because of the lead lengths, and I'm going to dress this back up in this area and tie everything back to this ground location just to clean everything up instead of looping all the way back over in this area. Alright, we'll take a close look at it again. Just a dry fit here. I'm going to go ahead and solder everything up at this location and go ahead and just clip this lead here and get this cap out so it doesn't confuse me later. But again, you can see I've got the 500 picofarad cap here, and then the what I say 0.002 or whatever this was, and then the other correct resistor here that replaces this one here. So let me just double check myself on the schematic one more time, and we'll solder this up right here on this end. Alright, looks like we're a go. Let me let that cool just for a moment and double check everything. Just make sure it looks good. Alright, what I'm going to do here on this picofarad capacitor is just wind it around the resistor here that's grounded. And let me just get a little solder on there now. See, it looks a little neater there. We'll tuck it in over here out of the way. And you can see the value. And if somebody needs to do some voltage measurements here, which would be me, off the pins, I don't have a component right in the way. That's always important when you can avoid cluttering up the pin locations. Alright, the other side of the resistor here again attaches back to the adjacent tube here, which is the 2A5 output tube. But check this out. You can see the when the ceramic cap was put in, there's really no solder even holding it in place. I'll put it back there for reference just for a moment, but that's interesting. Okay, let me go ahead and unsolder all this mess right in here as well and clean that up. You guys recall, this is where pins 2 and 3, the plate and one of the grids is where the output transformer ties in here on the 2A5 tube. We go. See if I can get in here and clean this up just a little bit better. Okay, there we go. Kind of tucked in there out of the way. And again, let me double check myself here. R3, okay, 100K. That's what we've got here. And again, I'll probably have my hands here in front of the camera for a bit, but what I'm going to do is get the 100 in here. Let's see, I want to do this. Okay, as such, you can see I've just looped it there, and I'll be leaving that loop or extra wire because again we've got another connection point here when I bring in the speaker and we reconnect it, so I want to use that for my solder connection. I'm just looking at that a little closer there. I'll go back to when I get done with the video and double check all my solder joints and clean everything up as well. Okay, moving right along here. Let me look back at this value here and just see if it was in tolerance. That was the, yeah, this one didn't even match the schematic at all. So it ties into this 400 ohm. I think that was 400. And when we fire this thing up too, I'm going to leave that most likely. Well, I don't know, I'll probably go ahead and replace it with a modern day. We'll see. But we'll check the current across there and just make sure whatever we go back with, we've got the appropriate wattage. R6 is a 500K and that was 2 meg and it read 2.9 meg. I wonder if that was done for a reason. Anyway, we'll go ahead and go back with what the schematic calls for again, a 500K. And we'll get the other side of this cap in here as well. And again, this was the location where the disc cap was not even soldered in. Look at that. No soldering on it. Alright, let me just double check my resistor value here just to make sure I'm good. And tell you what I'm going to do. We can check this cap one more time here. Again, that's a 0.02 microfarad. What I'm doing is just getting that gimmick back together for now. And let me just get it up here out of the way for a second. Okay, we only had a little ways to go, and my memory card filled up on the camera as I was recording, so you guys can see where I left off. Nothing earth-shattering. I did move this capacitor connection here, the ground point from here, and clean that up and reutilize this one. And you can see how I tried to keep the components again in a position where, you know, anyone that needs to come in here in the future and service the radio can do so without having the components again kind of clutter up the tube sockets. So again, not a lot to this little radio anyway. So I'm going to just go back and inspect my work one more time. Just go through all the solder joints very, very close, and make sure that I don't see anything that needs to be touched back up. And do one more cleaning. Again, I've already taken alcohol and went over the tube sockets. Then I used some cleaner as well on the bottom of the chassis. Then I've blew everything out as well with some forced air. But I'll put on my magnifiers and just go look at everything very, very close. Then up next, we'll do all the tie-ins. We'll get the speaker back on. I still got to clean it up, and we'll get the power transformer back in and tie that up. And if it doesn't take much time, we'll get back in here and bring it back up on the Variac and see what happens. Folks, thanks again for watching this segment.